Hello, I'm Rebecca the Maths Lady, and welcome to this video which is all about linear sequences. In this video I'm going to explain to you how you can teach children to be able to visualize sequences and instantly spot which ones are linear sequences and know why they are called linear sequences. And then I'll explain how we teach children to solve problems where there are missing numbers in linear sequences. So if you don't need this video, here's your skip link to your next one, which is all about algebraic notation. When you're teaching this topic, it's useful to use it to consolidate the topics of square and cube numbers and negative numbers. You don't have to if you haven't taught those topics yet, but if you have, it's great to look back at them now and make sure they appear again when you're teaching this topic, and I'll show you how to do that in this video. Here's a link to the video on square and cube numbers if you want to watch that one again, and here's a link to the video on negative numbers if you'd like to check in with that one. Okay, let's get started. So the best way to start teaching this topic is to give children some sequences and just let them examine them on their own or in groups and see if they can continue them and identify the rule for them. So here are some examples of sequences you might give them. So in this first sequence, the numbers are going up in fives, so the rule is +5, and the next numbers would be 34 and 39. This next sequence here, children can come to understand it in different ways. They might say, well, the difference is increasing by 2 each time, and be able to continue it because they've seen that. But it's also the sequence of square numbers, and it's a nice chance to just recap the idea of square numbers. So the next two numbers are 49 and 64, and the rule might be add 2 more each time or sequence of square numbers. In this third sequence, we're doubling each time, so the rule is ×2 and they can continue that sequence. In this fourth sequence, we're halving each time, so we're going to get 1 and then 0.5 or a half, and we're dividing by 2. Sequence E, do you recognise that one? That's a Fibonacci sequence where you add the previous 2 numbers together to get each result. So 8 is 3 add 5, 5 was 3 add 2. So the next number is going to be 5 add 8, which is 13. And the final number will be 8 add 13, which is 21. And this rule is add last 2 numbers together. And this final sequence, we're just subtracting 2. That's nice and easy. So the numbers are 7 and 5, and we're subtracting 2. They may not get all of that, it doesn't matter. Just have some rich discussions, let them play, get them engaged with the challenge of starting to analyse sequences. The next step, if you've got some blocks, it's great. If not, you're going to need to use squared paper. But it is to build these sequences, building columns of blocks to represent each number in the sequence, or colouring in columns of squares if you've just got squared paper. And it's really nice just to have an excuse to let children play with blocks again and connect them together, and every child can be comfortable and confident in what they're doing, even if they really struggle with number. So this first sequence here, if we analyse it, that's the sequence of square numbers. This second one, the rule is subtract 2. This third one, we're halving each time. And the fourth one, that's a Fibonacci sequence. If we place that on top of that, add the previous 2 numbers together, we get the next number, and that's always true. If we do that again there, you get your next number. Now what happens if we place rulers on some of these sequences? If you place it on the sequence of square numbers, it doesn't touch every number in between. There's a gap here. But if you place it on the sequence that's descending by 2, it really does touch each number. You've got a straight line there. That sequence is linear. Linear means to do with straight lines. This one here, dividing by 2, it's certainly not linear. Look at that big curve. This one here, where we're adding 2 each time, that's linear. And this one here, the Fibonacci sequence, that's not linear, that's a curve. So linear means straight line, and it happens when all the steps are the same size. And that only happens if you're adding or subtracting the same amount each time. It's the only way you can get a linear sequence. So your linear sequences are your sequences where all the steps are the same size because you are adding or subtracting the same number each time. So you could have done that building the sequences with blocks or colouring squares to get what looks like bar charts, where each bar is the size of the next number in the sequence. If you want to make sure your whole class get a deep understanding of what linear means as a word in terms of sequences, this is a very powerful way to do it. And by exploring this topic in this way, you're laying fabulous foundations for the future. Your child's got much more chance of understanding linear graphs, linear functions, or summating linear series, which is an A-level topic that many children of this age can do if they've been taught in this very visual way. I'll come back to that in the extension. But all these topics, linear sequences, linear functions, linear graphs, they're all closely related if you've got that visual foundation in place. And they're so much easier to learn if you have. Okay, let's have a look at filling in missing numbers in linear sequences. Here are some examples we're going to work with, and I'm just putting them up on this screen so that you can freeze this frame if you want to work on them with a student that you're working with. So how would we work on these? Well, this first one, that's clearly just going up 6 each time. So we can put down the rule, add 6. We can add 6 to 11 and get 17. And we can check that if we add 6 to 17, we get 23. It clearly works. We're done. This second one, it looks like we're subtracting 2. So let's just check 18, 16, 14. That's going to work. So the rule is subtract 2. And I would expect your students to be able to cope with that. But then it gets a little bit trickier. Have a look at this next question. How would your children understand that? Well, some of them may be very comfortable saying, look, we've taken 2 steps to get from 3 to 21 and we've added 18, so the rule must be add 9. And if we test that out, 3 add 9 is 12, add 9 is 21, add 9 is 30, 39, we're done, it works. But if you're working with a child who's not very comfortable with that, it's great to get them to build those numbers with blocks or colour them in squares, which might be ½ centimetre squares, then this fits on a page, leaving gaps for the missing numbers, and let them put their ruler on, puzzle them out, become comfortable with the answers, and then you can have that same conversation saying, well, we went up 18 in 2 steps, therefore we must have been going up 9 each time. And then you can give them some more questions like this to practice when they're not drawing. So if your children can follow this beautifully without those practical steps, that's fine. But if some are struggling, take the time for this. It's good fun. They can help each other out. They'll be happy working with blocks. And it becomes even more relevant when you look at this next question where a heck of a lot of numbers are missing. Can you do that? Well, given what I've just said, hopefully you can puzzle out we're moving 3 steps and we're going down 9. Therefore, it makes sense that we're going down 3 each time. So that will be 13, 10, and 4. And it does work. But again, you can build it with the blocks. You can build the 16, leave 2 gaps, build the 7, and puzzle out the stacks of blocks that work to make it linear. And then for those children who are struggling to do everything that we've just done in our heads, we've got something solid to touch and work with as we're explaining the logic we've just used. Children are doing these questions when they're just 10. They're still very young. Some of them are still struggling to work in an abstract way. Not all children will need the blocks and the graphs, but all will benefit from them because laying down those visual foundations of maths will support and connect their thinking about maths in the future. Right, let's have a look at this last one. What's going on here? Well, we've gone down 12 in 2 steps. That looks like we're going down 6 each time, so that would take us to 7. What's 6 below 1? And this is just a chance to practice our negative numbers. So that's -5, and we can get our number lines out with negative numbers on and counting sticks and make sure everyone's really confident. And we can make block graphs where the blocks point downwards for negative numbers as well. And what's 6 below -5? -11. It's just a great chance to practice and consolidate working up and down positive and negative numbers. So that's the main teaching for this topic. What about your extension work? There's a couple of topics you can look at. One is if you've got the first 5 terms of a sequence, could children predict the 10th term? Obviously they can get it by writing out every number, but if they predict it from the 5th term, can they get it right? And a lot of children will just double that 5th term because they're looking for a nice easy shortcut, and it doesn't work. And to draw out the fact that it doesn't work is really helpful, and if they can find strategies that do work, that's just fantastic. So just to illustrate what I'm saying there, that's the first term, second term, third term, fourth term, 5th term of a linear sequence. 6, 7, 8, 9, 10. What's the 10th term going to be? And a lot of children will say 22. But this sequence has only got odd numbers in, so that's a bit of a surprise, and it turns out not to be right. The logic they need is that we're adding 2 every time. We're moving another 5 steps, so we're going to add 5 lots of 2, which is 10, so that number is going to be 21. And of course they can check it. And you can use similar logic for any linear sequence. And you could ask about the 20th number in the sequence. The proper word for a number in a sequence is a term, so the 20th term. If you can introduce that language, that's even better because you're laying great foundations for the future. The other thing you can look at as an extension topic, I mentioned it before, it's an A-level topic. A-level is age 16 to 18. And this topic is about adding up numbers in sequences. So if we take a very simple linear sequence, just adding 1, and draw the graph of it, what's the total if we add these numbers together? And of course you can do 1, add 2, add 3, add 4, add 5, add 6. But we're starting to look for shortcuts. And we can get shortcuts if we look at this geometrically. Because if we put that block on top of that one, we'd get a tower of 7. And the same would be true if we put that 5 on top of that 2. And the same would be true if we put the 4 on top of 3. So we'd have 3 towers of 7, which is 21. And that does turn out to be the total. And you can use similar logic with different linear sequences and with more numbers in the linear sequence. If you didn't have the drawing or the block diagram, what we'd be saying there is if you add the first and the last, and then the next 2, and then the next 2, they all come to the same total, and so we can find a shortcut. And the more you do it, the more you see similarities in the shortcuts between different situations. So your takeaways from this video are that it's a really good idea to explore linear sequences in the context of other sequences, like sequences where the rule is multiplying by the same number each time or dividing by the same number each time, the sequence of square numbers, the sequence of cube numbers, which is really steep and curvy, and Fibonacci sequences, which come up so often in nature. It's a really good idea to build these sequences with blocks. Not all children will need that to be able to answer the questions they're currently doing, but it lays really good visual foundations for their future maths if you do it. Linear means to do with straight lines, and the linear sequences are the ones where if you put a ruler on them, that ruler nicely touches the corners of every tower of blocks. So they're the sequences that have steps of the same size, so you're adding or subtracting the same number each time. And once you've clearly established that understanding, you can use it to solve pretty challenging questions where there are missing numbers or several missing numbers in a row in a linear sequence. Thank you so much for taking the time to really deeply challenge yourself to understand what you're doing when you're teaching this topic. I hope you enjoy teaching it. and I hope you'll join me again soon for some more videos. The final 4 videos in this series of number aged 9 to 11 are going to be on algebra. We're now starting to make the transition away from representations with apparatus and pictures to representations with algebra, now that the children are older and they're getting ready for secondary school, for their next stage of education. So we want to lay those foundations now and use them to consolidate and reinforce everything we've done at primary school. If you'd like to find out more about which videos are available and which free worksheets are available for download, they're all in the description for this YouTube channel. It looks like it's the first comment just below the video. If you've any questions, please ask them in the comments or come and ask me live on Sundays at 9 o'clock on this channel, British time. Hope you're really enjoying your teaching with these strategies and you're able to make every single child you work with happy, creative and confident with their maths. Take care. Bye for now.